Okay, so we saw in the previous video that when you know the trigonometric ratios, that's not enough to figure out what the angle is because within one rotation from 0 to 2 pi, there'll be two angles with any given trigonometric ratio, and depending on if it's positive or negative, that angle could be in different quadrants. So it's useful to be able to figure out which trig ratios will be positive and negative in each quadrant. So we have a little kind of mnemonic device to help ourselves remember that. It's what we call the cast rule. The way the cast rule works is it tells you which trig ratios are positive in each quadrant. So let's just think about which ratios would be positive in each quadrant. Let's think about the second quadrant here. In the second quadrant, any point in the second quadrant is going to have a positive y value, because it's above the x-axis, and a negative x value. So sine is going to be positive because it's going to be y is positive, and r is always positive because it's a radius. So sine theta would be positive here. Cosine will be negative because x will be negative, and tangent will be negative because y will be positive and x will be negative, so you have one negative. In the third quadrant, y and x would be negative. Right? You get a negative y value and a negative x value, which means tangent would be a negative over a negative, so that would be positive. And the other two would be negative because both y and x are negative. In the fourth quadrant, cosine would be negative. Cosine would be positive because x is positive and y is negative, so the other two would be negative, right? You'd have a negative for this one and a negative for this one. And in this quadrant, all three would be positive because x and y are all positive. So we just say all. So this is where the cast rule comes from. You just take the first letter from each one, C, A, S, T. So it spells cast. Sometimes people don't like this one because you have to remember to start in the fourth quadrant, which you'd think you'd start in the first quadrant. But if you start in the first quadrant, that doesn't spell anything. So it spells something if you start in the fourth quadrant. There's other ways to remember it. A mnemonic device I've heard is all students take calculus. It's another way to remember it. That one's nice because you're starting in the first quadrant. But whatever way you use to remember it, doesn't really matter as long as you remember it. Okay, another thing we want to look at in this video is our special angles or our special triangles. So we've seen again in a previous video, we can figure out angles if we know a trig ratio by using our calculator. We can figure out a trig ratio if we know an angle, again, by using our calculator. But there's a couple angles, or a few angles, more than a couple, where we're just going to memorize the trig ratios. And those angles come from special triangles. So the first special triangle is an isosceles triangle. So it's a right angle triangle, which is isosceles. So if you have a right angle triangle which is isosceles, that means this angle would have to be a right angle, which in radians that would make this pi by 2. And then these two angles would have to be equal. In radian measure, the sum of the angles is not 180 because that's degrees, it's pi, because pi is equal to 180. So you have pi equals pi by 2 plus these two angles. So let's just say that's x plus x, which means pi minus pi by 2 is equal to 2x. So pi by 2 equals 2x, or x, the size of those angles is pi by 4. So these two angles here, and really it's just one we care about, would be pi by 4 in this isosceles triangle. That's a 45-degree angle in degrees. So now it's an isosceles triangle, meaning these two sides are the same and those two angles are the same. So now we can make these sides, it doesn't really matter, but we're just going to make them the easiest thing we could, which would be 1. So if these two sides are 1, then you can do Pythagorean theorem. I won't do it. but this side would end up being root 2. Just if you did a squared plus b squared equals c squared, you would get that this has to be root 2. So now let's just figure out the trig ratios on these sides. So your cosine ratio for a pi by 4 angle is the adjacent side over the hypotenuse. So the adjacent side is 1 over root 2. Root 2 is the hypotenuse. The sine ratio of pi by 4 is the opposite side, which is also 1, so you still get 1 over root 2. The tangent ratio of pi by 4 is the opposite side, which is 1, over the adjacent side, which is 1. So you get 1. So those are our tangent or our trig ratios for the pi by 4 angle, which you knew these from grade 11, but you thought of this as the 45-degree angle, but in radians it's pi by 4. So you need to know these ratios. If you know the triangle, you can get the ratios. It's nice to be able to do it without having to use the triangle. The other special triangle comes from, we look at an equilateral triangle. Equilateral meaning all sides and all angles are the same. Now, if all the angles are the same, then it's not a right angle triangle. We don't have a 90-degree angle, but we turn it into a 90-degree or a pi by 2 angle or right angle triangle by cutting it in half. So this becomes a right angle, which means this angle would be pi by 2. We'll just look at this half of the triangle. We won't worry about this half. Now this angle, which was the angle in an equilateral triangle, we know is in degrees pi by 6, but we figured out that in degrees pi by 60 degrees, but we know that 60 degrees is equal to pi by 6. Sorry, pi by 3. Pi by 3 in radians. And then this angle up here was pi by 3, but we cut it in half, so this one's going to be pi by 6. Okay, so we can use this triangle to get our trig ratios for pi by 3 and pi by 6. We just have to label the sides. Now the sides, again, we can make kind of whatever we want, whatever would be easiest. So this side I'm actually going to make 2, which means this big side was 2, but I cut it in half, so it's 1. And then I'd use Pythagorean theorem to get this side, which I'll let you do, but that's root 3. So our trig ratios for, let's do pi by 3 first. Sine of pi by 3 would be equal to the opposite side, which is root 3, over the hypotenuse. So root 3 over 2. The cosine of pi by 3 is the adjacent side, which is 1 over 2. And the tangent ratio of pi by 3 is the adjacent side, the opposite side over the adjacent side, which would be root 3 over 1, which is just root 3. And then you can do the same thing for pi by 6. The sine ratio of pi by 6 is so the pi by 6 is up here, so the opposite side is 1 over the hypotenuse is 2. The cosine of pi by 6, the adjacent side to pi by 6 would be root 3 over the hypotenuse is 2. So root 3 over 2, and the tangent ratio of pi by 6 would be the opposite side over the adjacent side, so you get 1 over root 3. So those 2 sets of 3 trig ratios for pi by 3 and pi by 6 are again ones you need to know. So you can memorize those 3 or 6, or you can always just use the triangle. If you know the triangle, you can usually get these pretty quickly. So that's usually good enough. Although once you do enough questions, like if you do these for a couple days, you probably end up having these pretty much down. It's the same as the 30, 60, or I guess 30, 60 angles you learned in grade 11, but now we're working in radians, so that's pi by 3 and pi by 6.